broader perspective on spillovers rather than just leakage, but trying to use a really detailed empirical data set that collected with Kim Carlson and lots of other people helping to try and measure the impacts of the RSPO. And in this case, we're going to try and see whether we can identify some pathways for spillovers resulting from the RSPO. So just a quick background on the study system. I think most people in the room are somewhat familiar, but most important source of vegetable oil in the world, palm oil. About 50 to 85% of Indonesian palm oil expansion has gone onto previously forested lands, and that partly has driven this high rate of adoption of eco-certification. Out of the agricultural commodities, it's one of the highest rates of adoption. About 20% are certified under the RSPO, and also a really high rate of zero deforestation commitments among palm oil companies. So that led us to look at what the impacts of the RSPO have been. So why would we think the RSPO would actually have an impact on deforestation? So there are 4 requirements in their principles and criteria that have a direct link to forests. One is that there's no primary forest clearing after 2005. Second, there's no use of fire for land clearing, so you might see less land clearing because one of the main tools for clearing that land is prohibited. Riparian buffer protection, and preservation of high conservation value forests. So if we bring those together, this is kind of a previous study that is in press right now at PNAS, but what we do is econometrically, using matching and panel methods, we compare the non-certified properties to the certified properties, look at changes in trends before and after certification, and what we find is that you have pretty good match in deforestation rates prior to certification, and then about a year before certification you get this divergence, and that stays somewhat consistent. So if we just look at the difference between our certified and non-certified properties, we see that drop about a year before, and it starts to taper off a little bit towards the end, so I think we want to have a longer data set in the future. But we do see a pretty significant effect that there's about a 20% reduction. There are some caveats. I'm not going to get into everything on this paper because I want to focus more on the question that we didn't tackle in this paper, which is what's happening in these non-certified properties. So we focused primarily on trying to see what's happening in the orange certified and largely ignore that process, which might actually give us biased estimates of the impact. So what's happening on these non-certified plantations? It's the main question of this work. How has the RSPO certification affected deforestation on non-certified properties? So there's a lot of simulation models and analytical approaches to trying to tackle that question. The approach that we take in this paper is really trying to make use of this detailed data set that we've collected, thousands of properties across Indonesia, 16 years of data on land use, and trying to use that to parse out maybe some of these clues that Jan had mentioned that there is some form of leakage. Empirically, people in the past have often used this approach of a spatial boundary and kind of building off this idea that leakage is going to happen most concentrated in the areas directly around the treated area. And I think that's most relevant in a protected area landscape. So a lot of the papers that have used it have looked more at protected areas. I've used it as well with Eric, looking at FSC, but I think what you end up finding is that this framing becomes less helpful when you're talking about these commodity interventions. You wouldn't necessarily expect the spillover from one palm plantation to really just affect those palm plantations that are within a 30, 50 kilometer buffer. The kind of theoretical basis for this estimation approach becomes much weaker and more problematic for the types of interventions that we're talking about here for a lot of the reasons that Eric and Jan touched on in previous conversations. So it's limited because the spatial patterns are proxying for the actual structure of spillovers. We actually have some priors on why spillovers are happening and what the mechanisms for those pathways would be. And we can use that within our estimation approach to try and get more precise estimates and also more accurate estimates of what's going on those non-certified properties. It's really problematic when the actors are more mobile or they have assets that stretch across large areas. So in this case, palm oil producers will often control properties in Indonesia, Malaysia. You know, they might be, if even that direct the activity leakage that Eric had mentioned, which is one actor moving across a boundary, the one actor in this case has another plantation on the other side of Indonesia. is that considered this activity leakage? Can we actually get at it with this spatial approach? And the answer is no. And then finally, this is a point that Alex makes in a paper with Juan Robolino, that this blends multiple effects. So we're basically collapsing all forms of spillovers into this one metric of a short distance and trying to figure out what's going on. That works in some policy settings, but not so well in this one. So what we're trying to do, and this is true to the goals of this workshop, it is a work in progress, so we're going to have some very preliminary results. But the general framework is that we're going to look at market structure rather than that spatial distance, maybe look at economic distance between different properties to see whether these transmission pathways are actually changing patterns of land use change on other properties. So rather than just drawing a buffer and seeing the properties within that buffer, we can look at properties that sell to a certified mill. So imagine that these two blue properties are actually selling to a mill that's located within that certified property. Do they experience a differential rate of deforestation compared to the other properties? Or you could imagine a property that belongs to the same parent company as that central property. Do they have a differential effect on deforestation rates? So the key point here is that the market structure rather than spatial difference might be able to help us partially isolate the mechanisms leading to spillovers and more accurately measure those spillovers. So just to put a little bit more meat to that and link it directly to some of the pathways that exist in the literature. So if we're thinking about the parent companies, this company owns both of these plantations. The orange one is certified, these pink ones are not. Let's maybe compare the patterns of deforestation in these pink plantations to the green ones and see whether, as a company gets more and more certified properties, is it changing its behavior on those non-certified properties. Why would we expect that to exist? One is slippage. So this is kind of came out of the Conservation Reserve Program literature, that you might actually have an input price effect. And so if a company is constrained in its inputs, it might reallocate some of those inputs to a different. So maybe for this kind of setting, we might think of management or other capital inputs that they would then stretch and put into a different deforestation frontier. Learning, so as the company becomes more aware of the rules and the expectations under the RSPO, maybe they start to implement those rules on other properties. You could also imagine that one thing that the companies will often say is that they are deforesting not because it's their action, but because the subcontractor has accidentally cleared a riparian buffer. So maybe they start to learn which of their subcontractors actually do a better job of following the rules under the RSPO and use those same contractors on their other properties. And finally, RSPO requirements. So the RSPO has kind of changed its requirements a bit, but now if you're a member and are certifying some of your properties, you actually have to start adopting some of those practices on your non-certified properties, or at least you're expected to. There's not the same auditing system in place, but you do have kind of a change in practices that's expected of you if you're a member. So that spillover effect, as soon as you start to certify some of your properties, you might start to see those beneficial effects on the other properties. Kind of the second framing is if you're looking at non-certified plantations, but that are part of these certified supply chains. So a mill can certify its holdings using mass balance, which says, okay, 75% of your production is coming from a certified estate. We'll allow you to certify 75% of what you sell. But they might still be buying 25% of their fresh fruit bunches from a non-certified plantation. They can't sell that as certified palm oil, but you could imagine that that practice actually gives a pretty clear transmission pathway for practices from the mill to those non-certified plantations. So having information about the structure of the supply chain could allow you to more clearly identify which plantations are being affected. So the two kind of pathways that I think are most relevant here are one, the output price effects. So this is the kind of standard market leakage that you have an increase in prices. Let's say the orange property has dramatically reduced deforestation. There's a lot of avoided deforestation. There's now a shortfall in fresh fruit bunch production going to the central mill. So maybe the mill increases the prices that it's paying for other production in that landscape for the other suppliers that are providing fresh fruit bunches. Second, you could have a positive effect that enforcement and learning, so from that central mill is being transmitted to the other plantations in that supply chain, and so we could have kind of a compensating effect where they're actually starting to set standards and demands of the other producers within that landscape. And finally, one other quick one, you could also imagine that kind of the government in the local area starting to change its practices. Okay, so we're going to jump a bit into the data and the methods. This is largely the heroic leadership of Kim and all sorts of different grad students and undergrads and people in Holly Gibbs' lab that have been diligently digitizing hundreds of plantation boundaries, combing through these RSPO reports. We're collecting information both on the boundaries of the plantations, but also on the ownership of all of those plantation holdings, and then now starting to get information on the supply chain connections. So we can say we have information, we're starting to digitize it on these certified mills, how much of their production is coming from these specific certified plantations, and then how much is coming from the non-certified plantations. I've been working with an undergrad at UCSB, starting to create this supply chain database. So we now have 127 refineries in this database, over 1,000 mills, 42,000 known linkages between the mills and those refineries, and then thousands of these supply bases or concessions plantations. So, this is our map of plantations, and what we've done, similar to the previous paper, is overlay those plantations on the deforestation data from Hansen et al. We do try and control for planted palm using Gonarso data, which was basically mapping planted palm, and look at the rates of deforestation on each plantation for each year between 2000 and 2015. So here's one example. In red, you can see a boundary of a plantation, and we can identify which parts of that forest were cleared in which year, and attribute that then to a deforestation rate. And our deforestation rate is looking at the amount of deforestation as a function of the forest that existed in that plantation at the start of the time period. So our spillover metrics, this is kind of the most work in progress. The distance to the certified plantation, partly just to check how our approach compares to that traditional spatial buffer approach. Then the share of a company's holdings that have been certified, so we know all of the properties that a company holds. We can look at how the share of that area changes in certification through time, and then the amount of those properties that are in certified supply chains. But that one, it's a little bit of a bait and switch. That database isn't complete yet, so what we're going to use for today's presentation is the share of the local mills that have been certified. So if we look at a landscape where a concession exists within kind of the supply shed area, how many of the local mills are certified at any point in time, which tells us basically whether that company, that plantation is facing a really high rate of certification, so all of the possible markets that it could be selling into have some association with certification. Eventually we'll shift over towards those direct relationships where we know there is a certified mill buying from that plantation. So to do this, we use a pooled fractional probit model, which is basically just an equivalent to a fixed effects model for this percentage dependent variable. So we want it to fall on the 0-1 interval, and we want to deal with these nonlinear dynamics to get the fixed effects, so that's the approach we take. If anybody's interested in the econometrics, I'd love to talk later, but kind of gloss over this right now since there's a mixed audience in the room. We use plantation fixed effects. Those are just the average in this pooled fractional probit. You use the plantation level average for all your explanatory variables, year fixed effects, and then time varying observables. So right now in the model, it's just precipitation and temperature. Okay, so jumping on to the very preliminary results. Yeah, I think we're doing well on time. So if we look at our spatial distances, this is, I actually do it at a whole bunch of thresholds because part of me was a little skeptical that people can ever actually know what this threshold should be. Maybe a little bit of comfort that this is the log distance. So here we're looking at about 3.6 kilometers, then we go up to 10, 36, 100, etc. Actually, I might be going in quarter increments there. So even more. But up here we're at about 1,000 kilometers, and here we're at about 3.6 kilometers, and seeing how changing that buffer changes the estimated coefficients in the model. And we see that we're actually finding generally negative effects, but not significant in each cases. And then as you get out to bigger and bigger thresholds, you're starting to get pretty small sample sizes, so the predictions become much more unreliable and kind of jump around all over the place. If we shift over to looking at the parent companies that owns certified and non-certified properties, this is the trend in green of the non-certified properties that have no relationship to a certified property. And then in purple or pink, we can see the same trend for non-certified properties that belong to a company that's pursued certification elsewhere. And what we end up finding is that there's not much of a difference there, that we're getting very parallel trends. Even after the companies start to certify, we're seeing a parallel trend in the rate of deforestation on those properties that belong to companies that have certified elsewhere. So partly this might be telling us that the RSPO's requirements aren't really changing the behavior of those non-certified but owned by member company properties the way that we would maybe hope that the RSPO would. More interesting one is within the certified mill shed. So here we're looking in blue at any properties that fall within the mill shed of a certified plantation. In the actual econometric model, I'm using the share of all the mills that are certified as the variable. And what you find is that it follows this parallel trend and starts to deviate in like 2013 and out, that you're starting to get lower rates of deforestation in the certified supply sheds as compared to the non-certified ones. And if we overlay what we're seeing in the certified plantations, that's even lower, but you're starting to see this kind of movement towards that point. And simultaneously what's going on is that there's a higher and higher rate of certification of all the mills over time. So you kind of expect that convergence. What does that actually mean? So if we take the average partial effect, which is how you convert these nonlinear coefficients into something that has some actual meaning, what we're finding is a 2.6 percentage point reduction in deforestation. In general, we're seeing like a 7% rate of deforestation. So that's cutting, if you go from a supply shed with no certified mills to one with 100% certified mills, you're seeing about a third reduction in deforestation on those associated plantations. So the conclusions from all that, a purely spatial method doesn't seem to kind of give us any indication of what the spillovers are, or at least not significant, able to detect significant effects. Same thing with within company spillovers. We're not really seeing any evidence that companies are reallocating deforestation or adopting sustainable practices on the properties that they control that are not certified. However, we are seeing that there seems to be some effect within those mill sheds, and I think we need to do a bit more to develop that econometric model a bit more, working on kind of a theoretical model that we couple with that to isolate those effects more directly. And then the net local spillovers appear to reduce deforestation rather than accentuate deforestation. So this doesn't capture those kind of global market effects. We're really looking within this landscape at what the spatial structure of these supply chains might tell us about the transmission pathways. The hope is that this helps us elucidate a little bit about the actual mechanisms that are at play in these spillovers. Again, it's not a smoking gun. Sorry to disappoint, Javier, but maybe we can, kind of in light of Jan's presentation, reflect on these to build a little bit more of an evidence base of the actual mechanisms that are at play. Oop. And so the future work on this research, where I'm hoping to take this paper, is to integrate the full supply chain database. So working now with the folks at Trace to build this out more fully, very actively working on digitizing as much of this information in these reports as possible. Anybody has extra undergraduates that want to join in the effort, that would be great. And then explicitly include the intensive and extensive dynamics. So Kim's leading a project looking at yield responses to the RSPO. I think if you're trying to understand these spillovers, especially the market spillovers, understanding those yield dynamics are really critical. So hopefully that can link into this research. And then finally, more clearly aligning the models with the spillover mechanisms. So right now, we're still kind of capturing a bunch of different things within a single variable, and hopefully by structuring it more theoretically, we can start to isolate those effects. So I think that's it, and yeah, right on time.
Thank you.